of myself and Andrew Torrance and Judith Wolfe. Right there, yes. The lectures have been funded since 2007. We have 3 or 4 lectures a year by the John Templeton Foundation. And you can see all of the previous lectures on the website here. You can see all the details also of James Gregory himself. He was a key scientist in the 17th century. Details are on the banners outside and also on the walls outside the lecture theatre, but 1 floor up. So if you go out the lecture theatre and then up the stairs, you will see a lot of details on the walls about James Gregory and his history. He was one of the, he made some fantastic discoveries, most of which were not well known to people, so we've been trying to advertise them. In mathematics, he was one of the 3 founders of calculus. In physics, he discovered the diffraction grating. And in astronomy, he designed the Gregorian telescope and also laid down the first astronomical meridian line. And you can see that projected across the pavement in South Street outside Parliament Hall. I'd be grateful if you could fill in this questionnaire that you at the end that you've been handed as you came in. And if you'd like to receive an email notification of future lectures, then either email me or put your name and email on that questionnaire. Now, it's a great, real pleasure for me to introduce Jeff Schloss. You shouldn't say this when you've been drinking, I haven't, but anyway. Jeff is a really good friend. He's from Santa Barbara. He did his PhD in ecology and evolutionary biology. He's a distinguished professor of biology there. And in the light of phrases such as the survival of the fittest, or the selfish gene, or nature red in tooth and claw, he's been spending many years asking questions such as, did God create us or did evolution create us? Where did altruism and love come from? How did morals and religion arise? He's also, though, a senior scholar at the Biologos Foundation, which is the main organisation that is putting forward, I think, a reasonable approach, a reasonable description of the relation between science and faith. It was founded in 2007 by Francis Collins, who was at the time the head of the Human Genome Project, and it put forward the belief that God created all things and that evolution is the best scientific description for diversity of life on Earth, and that there is no contradiction between these 2 statements. So, the title of today's lecture, I must tell you a little bit more about Jeff. He's edited or written several books, one on altruism and altruistic love, one on evolution and ethics, one on the believing primate, scientific, philosophical and theological reflections on the origin of religion, and then more recently, understanding moral sentiments. So I would recommend these to you. The title of today's lecture, though, is Does Evolution Lead to Love? So please give him a very warm welcome.
Thank you, Eric. It's wonderful to be with you. I have to begin with the anticlimax of launching a PowerPoint, which will just take a second. So it's wonderful to be with you. I want to begin actually with a story about my son Gabe when he was very young, maybe 3 and a half or 4. You know, one of the things about being a parent is you get to see the world through eyes of someone just encountering the natural world. I've never really thought much about when is the first time that somebody recognizes an aspect of natural regularities that we take for granted that he or she hasn't seen before, and this was a sunset. I was holding Gabe in my arms one evening when we walked out the door. Santa Barbara usually doesn't have very conspicuous sunsets. We don't face west, and we often have maritime fog, but this was a glorious sunset. The sky was ablaze hemispherically, and Gabe looked at it. I'm holding him in my arms, and he looked at me, his eyes just dilated. His lips literally quivered. And he said, "Daddy, look, God painted the sky." And it was a touching but a painful moment for me. I had to tell him, "Gabe, that's stupid. God had nothing to do with it. That's merely merely the differential scattering of light through a particularly enhanced atmosphere." No, I did not say that. I actually said, "Yeah, God makes pretty things, doesn't he?" With the sense that even when Gabe ever studied science, which it turns out he did, that he might view the laws of optics as simply God's brushes, means by which he created things. He'd have to rely on other kinds of arguments for whether there was a being like that or not, but a natural description doesn't necessarily subvert a belief in a creator. Actually, here in the UK, William Whewell, who actually invented the term scientist, along with osmosis, ion, conductivity, claimed that we can perceive that events are brought about not by an insulated interposition of divine power, exerted in each particular case, but by the establishment of general laws. Whewell actually went on to edit the Bridgewater Treatise, works in natural theology, and he also personally encouraged Darwin, after he got back from the Beagle, to become secretary of the Geological Society of London. So here's where you want me to say, or where you're expecting me to say, or the introduction from Biologos might expect you to hear me say that, well, just like a sunset, evolution is God's brushes. Well, I happen to believe that, but it's not quite so easy. And it's not quite so easy for two reasons. First of all, while the existence of natural explanations of things may not subvert belief in a creator behind those things, we're left with the question, though, is the quality or structure of those natural explanations concordant or discordant with belief in a creator? And in fact, evolutionary theory has been claimed, not just by nervous Christians, but by many people, to raise profound problems with faith. And the second reason it's not so easy is because in the tradition of the Abrahamic monotheisms, there is actually expected to be some degree of concordance between the natural world or creative order, what some theologians call natural revelation, and biblical or special revelation. Way back in the Hebrew tradition, the 19th Psalm says, "The heavens declare the glory of God." And yet it also says, "The law of the Lord is perfect, enlightening the soul." So these two streams of insight are believed, at least in the tradition of biblical monotheisms, to be very important. And in fact, this has become known as the two books notion, that we come to know God through the creation and the creator. Francis Bacon, sometimes called the father of the scientific revolution, said, "To conclude, therefore, let no man out of a weak conceit of sobriety or an ill-applied moderation think or maintain that he can search too far or to be well studied in the book of God's word or in the book of God's works, divinity or philosophy, but rather let him endeavor to an endless progress in both." Now, interestingly, this quote from Bacon, Darwin put on the frontispiece of his Origins. And right above it was the quote I just shared with you from Whewell. So here's the question about evolution. Can we make these things work together? It's not just nervous or literalistic Christians, but there's many, I think, fair-minded people have acknowledged difficulties here. So Dan Dennett, in his book Darwin's Dangerous Idea, says those evolutionists who see no conflict between evolution and their religious beliefs have been careful not to look as closely as we have been looking. What kind of conflict? I mean, there are different scales or levels of conflict. One is just historiographic issues that emerge from one's reading or exegesis of the biblical text. How old is the earth? When and where were the first humans? I'm not going to treat those. The next level might be what you would call doctrinal issues. What does it mean to be made in the image of God? What does it mean to have a fall? And what relationship does evolution have to those issues? What I want to wrestle with a bit here, and shockingly superficial given the amount of time, is yet a third level. Might be considered metaphilosophical issues having to do with the very coherence of theism. That's what Dennett had in mind. And therefore, his subtitle, Evolution and the Meanings of Life. So there are a number of those issues, but a couple are. First of all, is there any rationale or warrant to thinking that life itself has a purpose? So in an influential article a while back, the philosopher Alex Rosenberg said, Darwinism puts the capstone on denying that there is any meaning or purpose to the universe, its contents, or its cosmic history. And by the way, the title is called Darwin's Nihilistic Idea, Evolution and the Meaninglessness of Life. He was referring specifically to Dennett's subtitle, and he thinks that Dennett didn't go far enough, that actually evolutionary theory subverts the very idea that life has meaning. He's not talking here about evidence for or against an intelligent designer. He's just asking, within the context of an evolutionary view, is there any sense of directionality or expanding purposiveness which we might expect across history if there were a creator? Now, secondly, the second issue is, if there is, it certainly doesn't look like it could have any consonance to love, which in most religious traditions is viewed to be the ultimate end of existence. But there have been many representations of evolutionary theory that suggest it's inconsistent with this. So George Williams says, natural selection is a process for maximizing selfishness. Michael Gisel says, no hint of genuine charity ameliorates our vision of society once sentimentalism has been laid aside. And I love this little essay by David Oakes. For followers of Darwin, the familiar theological problem of evil was turned inside out. Evil could henceforth be assumed, and the existential paradox, which demanded explanation, became, in fact, the problem of goodness. Now, by the way, as an interesting aside, David Oakes is a wonderful writer. He has poetry and novels about the earth and environmental care. It turns out that as a student, he went to my institution, Westmont College. And he is also very candid about saying that faith has no credibility for him anymore. So here we go. I want to do a couple of things. I want to look at the question of evolution and purposelessness, and then ask how it connects with love. I have to both invite you and apologize in advance. I know we're on a university campus here. This is not an academic lecture. I was told it's pitched to a popular audience, so I'm going to cover a wide range of issues. Pretty superficially, but I hope not errantly. So Stephen Gould says that there are no trends worth speaking of in evolution. He has an image. A man staggers out of a bar, dead drunk. He falls down into a stupor. If there were a god behind evolution, we might think that it would have to be Bacchus, the god of wine, and that the universe is drunk. So let's take a look at this. Two different things. First of all, there's been an emergence of notions of what are called major evolutionary transitions. Now, by major transitions, I don't mean the development of major innovations like a nervous system or backbone or moving from the water to the land. What's meant by major evolutionary transitions is a series of thematically consistent steps in the scale of organization of life. So, for example, the transition from an aqueous mixture of molecules, some of which may have been self-replicating, into membrane-bound protocells, where now these molecules have their lives, in a sense, bound together. The transition from prokaryotic to eukaryotic cells, simple cells without organelles. The theory is that they actually symbiotically came together, and now previously autonomous cells were bound together to form a new kind of cell, a more complicated cell. Of course, the transition from unit to multicellularity, autonomous cells coming together to form organisms that couldn't do what isolated cells themselves could do. This one actually disputed about whether it constitutes a transition, but advocates say, same thing. Previously autonomous organisms now need each other to reproduce. From solitary individuals to social or eusocial individuals, organisms that, again, need each other to function, and in so doing give up a certain degree of biotic autonomy. And then lastly, I was a little surprised to see this in the list of many advocates included the transition from primate to human sociality, which includes symbolic mediation of cooperation and a number of special cognitive capacities, which we'll mention in just a bit. All of these transitions involve not just cooperation, but obligate interdependence, where an organism gives up previous autonomy for involvement in a higher level entity with increased function. Sometimes they're called evolutionary transitions in individuality, or ETIs. By the way, the interesting thing about this last transition, the human transition, is it's actually debated whether, amongst my colleagues, about whether it should be included. In my own view, is that the reason it's debated is because it may be a transition that is stuck in the middle. On the one hand, we humans are obligately interdependent. On the other hand, we have not given up reproductive autonomy. And this is something that the evolutionary biologist E.O. Wilson has reflected on for much of his career. So, reflecting on these major evolutionary transitions, Richard Michaud says, cooperation can now be seen as a primary creative force behind greater levels of complexity and organization in biology. The evolutionary biologist Martin Novak speaks of the snuggle for existence and not just the struggle for existence. Now, by the way, I don't want to oversimplify here, because at every stage of cooperation, there's the possibility for defection. And now defection at multiple levels. Defection at the level of previously existing entities, and defection on the new entity versus the whole. So an example with this exists at the genetic level and the cellular level. A defector cell at the cellular level that pursues its own reproduction ahead of the entity is called cancer. So at every level you need defection controls, but evolution has achieved that in a number of ways. Turns out then that this cooperation is not just an outcome, but in some sense a driving force of ensuing evolution. In fact, it creates possibility space for evolutionary innovation to move into. But how about this question of progress? So if there were purpose in evolution, we would maybe expect some sort of discernible progressive thematic directionality. Steve Gould says not only are there no trends we're speaking of, but progress is a noxious, culturally embedded, untestable, non-operational, intractable idea that must be replaced if we wish to understand evolutionary history. I think he doesn't like the idea of progress. Now, in one sense, he's completely right. Progress is not a scientific idea insofar as it entails change in a valued direction. Science can't decide what to value. But if we, by extra-scientific means, decide what's valuable, science can answer empirically the question of whether there's historical change in a trajectory consonant with that direction. Should, though, also say one other thing. The term progress is a funny word. Sometimes it means just what I said, change in a value direction. But physiologists speak of progressive processes that are autocatalytic, where one stage stimulates the next stage, but it may not be valued at all. For example, there's progressive shock and progressive hypothermia. These processes are progressive, where a former stage stimulates the development of a latter stage consonant with the direction. Are you with me on that? So we have two different notions of progress. I want to argue that actually both are evident in evolutionary history. But what is not the case, and here I'm right on board with Gould, is that somehow, and I'll use his very words, he says, progress marks the definition and central driving principle of evolution. That need not be the case. It need not be the bottom line driver of evolution, but we can still ask the empirical question of whether there are progressive dynamics at work in evolution. So here we go, and here's where I have to apologize, but I hope this is fun for those of you who aren't specialists. We can just look at certain changes over evolutionary history. So Dan McShay at Duke has done a lot of really fascinating work in these questions. Cellular diversity increases over time, just the number of different specialized cells that organisms have. Metabolic intensity increases over evolutionary time. Now look what we have. We have more cells that are specialists of different kinds, and we have more energy. And that means that living systems can get better at the things that living systems do. For example, homeostatic precision. That just means how well you regulate what's going on inside of you in contrast to where the environment is pushing you. This happens to be temperature, but it's true with osmotic concentration, it's true with pH and acidic contribution. Living systems get progressively better at regulating the inside. In fact, in some views, that's what being alive means. It means being in controlled disequilibrium with the environment. Parenthetically, Paul seems to have this in mind in Romans 12 when he says, "Be not conformed to this world, but be transformed by the renewal of your mind." So, as an aside, even spiritual life is taken to be controlled disequilibrium with the pressures of the surrounding culture. By the way, not just control of temperature. This is an area that I have been interested in previously. The actual body temperature increases over time. Now, we know, given the dependence on temperature of chemical reaction rates, that higher body temperatures have faster chemical reactions, meaning locomotor speed, reaction time, sensory time, all seem to increase over time, as, by the way, do sensory accuracy. I wouldn't have predicted this when I was a graduate student in evolutionary biology, but this has become a really fascinating area of emerging study and consensus in what is considered biotic autonomy, the capacity of living systems to be alive. So Bert Rosenberg has written a wonderful book called On the Origin of Autonomy, subtitled A New Look at Major Evolutionary Transitions. He's arguing that these transitions enable living systems to have more of the qualities we ascribe to life to begin with. Parenthetically, there is a movement, very vibrant in America and being exported, called the intelligent design movement, that argues that, amongst other things, that the information fueling life couldn't have emerged by natural processes. I'm not going to comment on that, but I will comment on the irony that this movement actually doesn't address what that information accomplishes. To give an example, it would be like asking whether a certain book could have emerged by monkeys typing at typewriters without actually reading the book and seeing whether it was a phone directory, the Bible, Shakespeare, or Hitler's Mein Kampf. The fascinating thing about actually reading the book of life is that itself is, well, to quote Darwin, there is a grandeur in this view of life. I would say it's remarkably consonant with theism, but not demanding of theism as part of the explanation. So 50 years ago, the chemist and philosopher Michael Polanyi, in a prominent journal, Science, said, "The evolutionary sequence gains a new and deeper significance we can recognize in a strictly defined progression rising from the inanimate level to ever higher additional principles of life." What he was recognizing is what I shared with you, but that view has been rather ostracized after Polanyi. This new work has rehabilitated it. So speaking on the major evolutionary transitions, Carl Sagan says, "This progress," he had just quoted Polanyi, "nowadays described as a series of major transitions in evolution is often due to the emergence of new cooperative groups." So there is this progressive sequence. But what on earth does that have to do with love? There is increasing biotic capacity. There's increasing cooperative interdependence. That is love. Maybe a necessary substrate for love. Well, I want to just mention a couple of additional substrates, additional trends. We have an evolutionary theory within kinds, something called Cope's rule, an increase in body size over time. There are lots of important and still unresolved debates on this about whether that's an eliminative or average trend. In mammals, for example, it seems to be relatively undebated. Now, interestingly, along with body size, lifespan correlates with body size. Now, this has a couple of implications. And by the way, aside from body size, it looks like over evolutionary history, there's simply an increase in maximum lifespans. A couple of implications. First of all, again, with just mammals, reproductive output declines with increased body size and lifespan. You live longer, but you have fewer offspring, suggesting, by the way, greater investment in offspring. The second thing is we have associated with, this is hopelessly superficial, but there's evolution in both brain size and structure from what's called, overly simplistically, the reptilian brain or brain stem to limbic to neocortical areas of the brain. And within that, there's actually an evolutionary increase in neocortical area. Now, we can talk about, and actually Kevin Leyland could really talk about the kinds of cognitive capacities that are associated with this. But this increase in neocortical air volume also occurs across primate history. And what we know about just raw neocortex size is that it scales to social complexity. So a worker at Oxford named Robin Dunbar has done a lot of work on this and find that group size and social complexity scales to neocortical size. And here we are. Now, one last little tidbit, just because I think it's kind of fun. Body shape, construction, and symmetry. This doesn't translate across the Atlantic, but in the U.S. we have a phrase called happy as a clam. The fact is, if a clam were happy with a rigid exoskeleton and radial symmetry with no head and no face, you would never know. But once we get the emergence of flexible bodies and bilateral symmetry, we begin to get the ability to communicate between organisms. Here's an ant giving an alarm call. Here are two ants exchanging chemical signals. Dude, St. Andrews students have great food crumbs in their rooms. And then as we go up the vertebrate continuum, we have a process called cephalization, with the emergence of heads. And then the flattening of heads to reveal faces. The retention of these flat faces is a process called neotenization. So that the young of most mammals have very flat faces, which are wonderful display for emotions and internal needs. But with many, think of a puppy versus an older dog, those faces lose their flatness, not with primates. Primates continue to have these neotenous faces, which almost invites us to ascribe emotion. Should I go to St. Andrews or Edinburgh? Humans have the most neotenous faces that retain them most into adulthood, and we have hairless neotenous faces. The face is an amazing display for emotion. Humans are the only organisms that can convey blushing, for example. Some say we're the only organisms that need to. By the way, this neoteny is part of the reason that many humans may choose apes or little monkeys for their children's toys. So here's a little girl with her pet ape, and this little girl grew up into Jane Goodall. Studies of audience response surveys to Mickey Mouse showed over the years from the 1940s to the 1970s that they responded more empathically to Mickey as he became more neotenous. Now, the people who did these surveys didn't have any knowledge of neoteny. They just did surveys. Steve Gould did this work. He just went back and looked at Mickey and graphed eye size and forehead size and facial flatness size. Mickey becomes more neotenous over time. So have we. Okay, so what do these substrates have to do with actual loves? I have actually been working on evolutionary accounts of the emergence of altruism, a particular form of love, but I just want to quickly survey some current thinking on a number of kinds of love. These are recognized as far as the Greeks. C.S. Lewis has a book called The Four Loves, where he looks at some of this. Let's start with family and parental care or love. Now, early on, organisms in the evolutionary sequence don't appear to exhibit parental care at all. There may be parental investment in eggs and little parental care. And what we begin to see is the emergence of parental care. At the beginning, it may be egg guarding from predation. And a sequence of investing more into fewer. And that's even true across the mammals. So the first mammals were small and believed to be short-lived mammals with high reproductive output. And what we see is a continuum. By the way, biologists call this process K selection. And interestingly, this was the only trend in evolution that Stephen Gould expressed endorsement of in one of his very first book, Ontogeny and Phylogeny. So progressive investment in a fewer number of offspring. Primates are the most K-selected. Their investment continues for the longest period of time. And humans are highly K-selected. If some of you are St. Andrews students here, you may still be invested in by your parents in terms of tuition. This continues. Humans have what's been called the grandparent effect. And so it's not just parents, but grandparents who get invested in their offspring's offspring. We know that this is in part mediated by the hormone oxytocin, which was known to be involved in milk letdown and labor contractions, and later found to mediate maternal-infant attachment, and subsequently in biparental care species, both male and female attachment. There are a number of studies that link the provision of parental care and attachment to various health outcomes of emotional health, physical health, and even the development of sensory acuity. The really interesting thing is most recently we have found that some of these in attachment deprived children are heritable because it results in the methylation of the oxytocin molecule, something called epigenetic inheritance, where the gene itself isn't changed, but the surrounding chemistry that influences the expression of the gene is changed, and that can be inherited. So, how about organisms where care is so demanding that it may require two? So some quick comments on biological mediation of love and quote-unquote marriage. A number of my colleagues like to speak of romantic attachment as a twofold process, getting beyond just sexual attraction to involve, first of all, an interpersonal attraction stage, the falling in love stage, which may be mediated by a number of chemicals that are stimulant in nature, one of which is phenylethylamine, also found in chocolate. There have been some really fascinating brain imaging studies on this that relate the degree of cerebral stimulation to self when they show, these are all college students, 2,500 brain scans of college students. This is work done by Helen Fisher. And the degree of unlovedness was correlated to the degree of neurostimulation. Now here's the problem, and Fisher points this out. These feelings and the secretion of these molecules are not enduring. They may last several years, and it's not clear that we could sustain being in love for more than several years. I get, and many do, obsessive. Every napkin I'm writing a love poem, I don't want to do my work. So what mediates then longer-term attachment? A sexologist who died a few years back at Johns Hopkins University named John Money, he was a psychiatrist, and he had a counseling practice for individuals that he called love junkies. By the way, Money had no religious or moral commitment to these issues. He just found that certain people seemed to be addicted, quote unquote, to the rush of sequential falling in love, and they weren't happy. And so he posited the existence of a second stage of love, which he called attachment stage, which is characterized by different feelings and perhaps regulated by different neurological processes altogether. We have since discerned, again, our old friend oxytocin here, another related molecule called vasopressin, seems to mediate attachment in pair bonding. Initial studies of two different species of rodent called the prairie vole and the bank vole. The prairie vole is monogamous, has a mate for life. It's also highly social, stays with the partner even during periods that aren't the breeding season. And we found that the monogamous prairie vole had a gene, oxytocin, actually we looked at both oxytocin and the vasopressin gene, that was absent in the bank vole. You can take this gene, the head of U.S. National Institute for Mental Health, Thomas Insel did this work, actually transplant it from the monogamous to the promiscuous vole, and it exhibits behaviors consonant with the monogamous vole. So, like parental attachment mediated by oxytocin, it looks like, oops, I'm going to skip this. It looks like monogamous attachment may also be associated with various measures of both physical and mental health. Lots and lots of studies on this, and many of them have been very poorly designed. They've been cohort studies that just looked at married, single, or divorced people But the direction of causality, we're unsure of. It could be that if you already have problems, it's harder to get married or to stay married. So I find there are literally hundreds of articles on this. Many of them are very bad. There's a recent review article, and by the way, if you're interested in any of this stuff, any of you, I would recommend an article published just a year and a half or 2 years ago in the Proceedings of the National Academy of Sciences by Tyler Vanderweel. He has a joint appointment in biostatistics and epidemiology at the Harvard School of Public Health. And Tyler takes aim at a lot of these bad studies, but he also focuses on very well-designed, much fewer in number, longitudinal studies that control for initial variables. And he's looking at both family structure and marriage, and he also looks at religion here. So really cautious, open-minded, and well-done article. Okay, one last thing. We may be biologically endowed for attachment, but biology is variable. And this very gene that I mentioned before, vasopressin, it turns out to be polymorphic in human beings. We have different versions of them. And some versions are correlated with attachment difficulties and marital problems. So attachment is not the same as marriage. And in fact, biology may be receptive to this particular kind of loving relationship, but it's not the whole story. And in human cultures, at least, many of them have developed the cultural innovation of marriage, which is a vow, and not just allowing attachment to do its work. The German theologian Dietrich Bonhoeffer, who was imprisoned in concentration camps and ultimately killed for his resistance to Hitler, wrote his niece or his nephew, I don't remember which, a wedding sermon from the concentration camp. And Bonhoeffer said, it's not your love that sustains your marriage, but from now on, your marriage sustains your love. That in other words, this human commitment and culturally devised adaptation is important to undergird the genuine biological but biologically frail capacities. Another is an article by evolutionary biologist and anthropologist colleagues in the Proceedings of the Royal Society, looked at the spread of this cultural innovation of monogamous marriage. They were just puzzled by it. So not only is marriage not necessarily biologically innate, but not all cultures have had it, at least monogamously. And these folks looked at both the historical spread and also the cultural implications of monogamous marriage, which included a reduction in male violence and homicide, an increase in those societies that had it, in educational involvement, and including, and especially for women. And in one sense, not totally surprising to biologists who recognize, in general, a reduction in intramale aggression in monogamously reproducing species. So Oscar Wilde said one should always be in love, and that's reason why one should never marry. What I just shared with you suggests that's not altogether true, and just as one little interesting PS to this, Helen Fisher brought in married people and looked at neurological brain scan activity and found that actually in those couples who remained married, brain response actually scaled positively to years married. Okay, well that's family. But how about beyond family? And just looking at cooperation, for example, lots of species cooperate in social units that aren't strictly kin delimited. Now, one explanation of this is simply reciprocity. That you scratch my back, I'll scratch yours. And quite literally, you give me a back rub, I'll give you a back rub. The behavioral neuroeconomist Paul Zak has actually brought people into the lab and had them give each other just 1 minute shoulder rubs. And guess what? They release oxytocin. Now, it turns out there has to be trust between these individuals. If a stranger comes up to you and does it, probably won't work. So you have mutualistic reciprocity, encouraging commerce, cooperative commerce, and perhaps, who knows, in human beings, even love. But it's not that simple. I mentioned to you that at every stage of cooperation, there's the possibility for defection. And so it turns out that at every stage, defection control, and in human cultures, punishment turns out to be important. It may be that even primate cultures have a sense of fairness, and they're willing to risk payment to punish others, and even relinquish their own reward in certain situations that seem unfair to them. So here's a kind of a viral experiment done by Franz de Waal and his student Sarah Brosnan, in which they trained capuchin monkeys to give them a little pebble in response to a reward. The reward could be a grape, which they love, or it could be a piece of cucumber, which was okay. Rational self-interest theory suggests that you should also always accept something, but that's not what happens.
Grape, and you will see what happens. So she gives a rock to us, that's the task, and we give her a piece of cucumber and she eats it. The other one needs to give a rock to us, and that's what she does. And she gets a grape, and she eats it. The other one sees that. She gives a rock to us now, gets again cucumber.
So actually, this is a really cool experiment. It turns out that there has been some controversy about the interpretation of the experiment. Is it, I'd rather have nothing than being treated unfairly? Sarah has actually replicated these experiments with capuchins isolated, and if they know there's a grape there, even if their confederate didn't get one, they may not accept it. So the interpretation, I showed it half for fun, but half to give an idea of work that's going on in these areas that is as yet unresolved. But how about beyond reciprocity? Humans, but it seems perhaps some organisms, behave cooperatively and even affectionately with individuals who have no clear benefit in terms of mutual grooming. There are even interspecies friendships, if you want to consider it that way. The evolutionary anthropologist has actually spoken of friendship as cooperation without counting. It's not that there's no mutual concern in friends, it's just that they're not strictly reciprocal. And in fact, there's something that I hope many of us resonate with. To the very extent that somebody is vigilantly reciprocal, they haven't become a friend yet. For me, a kind of a favorite moment is if I'm sitting in my living room and somebody's sitting there with me and he gets up and walks into my refrigerator and just grabs something to eat without asking. I think, now if it's too early, it feels presumptuous, but I think, yeah, we're friends. So Sarah talks about friendship, cooperation without counting. Human friendships seem to transcend the calculus of kin selection or reciprocity. This kind of relationship defies the logic of evolutionary theory. Now I have to be clear here. She is an evolutionary anthropologist, and she has developed, along with others, an evolutionary account. One of those accounts entail, this was developed by the evolutionary psychologists Don Tooby and Levi Cosmides. They do it as a solution to what they call the banker's paradox. The banker's paradox is you most need a loan when you're least loan worthy, when you're least credit worthy. And they argue that in a species with a long lifetime, there may be periods in our life where we're simply unable to repay a favor. And a friend is somebody who shows up and sticks with us anyways. C.S. Lewis argued that friendship was the least biological of our loves because it wasn't tied to reciprocity. He's right that it isn't tied to reciprocity, but it may be biological in the sense that it meets a unique need for a long-lived, highly social species. And in fact, by the way, we've found that mortality itself scales to people's self-professed account of their own friendships. Now you might think, yes, we all need friends to support us, and if you got them, you'll live longer. Not so clear. So we've known for a long time that people diagnosed with terminal diseases live longer if they're in support groups. Stephanie Brown and Randy Nesse at the Institute for Evolutionary Medicine at the University of Michigan went back and got records, corrected them for initial state of the disease, and then followed up to see who was primarily giving and who was primarily receiving support. The takers actually had higher mortality than those not in groups at all, and the givers were the ones who had lower mortality. If in fact it's true, by the way, that friendship in some sense is an adaptation to the banker's paradox or uncertainties over a long lifespan, we might expect that as those lifespan approaches its end, that investment in friendships or the development of new friendships declines. So work with chimpanzees suggests that that's actually true. That grown-up chimps are less likely to help distressed friends, and a number of sociological studies say that that seems to be true of human beings too over the lifespan. Maybe that's just due to tiring out, but looking across the audience here, we've got a range of ages. For those of you in college, this is a time that many people look back on as an opportunity to forge lifelong friendships. Okay, lastly. Human beings in particular don't just help, cooperate with, or grow attached to family or friends. They also cooperate across large expanses, social expanses. Human cooperation exceeds that of all other species with regard to the scale and range of cooperative activities in a Royal Transactions paper. E.O. Wilson, and this is now 40 plus years ago, in his book Sociobiology, claimed man has achieved, I think we would say humans have achieved, an extraordinary degree of cooperation. Exactly how he alone has been able to cross to this pinnacle is the culminating mystery of all biology. So we've had 40 years to work on this. This, in fact, is the talk. Starting here is the talk I've considered giving and maybe should have given. But a couple of things in closing. First of all, biology alone may furnish the substrate, but it doesn't get the job done. That certainly the innovation of social norms extends the boundary of social cooperation. So the behavioral economist Ernst Ferris says human societies represent a spectacular outlier with respect to all other animal species because they're based on large-scale cooperation among genetically unrelated individuals, and including individuals, by the way, with whom they had no prior reciprocal exchange. So social norms are huge. There's been a debate between somebody like the primatologist Franz de Waal argues against what he calls Vernier theory, that somehow these social norms are imposed on us to get us to do what we're not biologically disposed to do, and argues for a more innate dispositions to these domains of cooperativity. I would actually say this is a false dichotomy, that social norms aren't necessarily an overriding or repression of innate dispositions. They may be devices, social innovations by which they're extended. And, by the way, not just extended perhaps, but perhaps even fulfilled. So, lastly, within the last decade or so, they've been a lot of work, not just on the development of social norms, but in the way in which religion may interact with these norms to expand and sustain the unique scale of human sociality. So a review on this published in Science about a decade ago now, and there's been an updated version by Ara Noordzaya on the origin and evolution of religious pro-sociality, makes the case that the origin of moralizing gods was instrumental and effective in expanding the scale of human sociality. In a way, this is a revisitation of Voltaire. If God did not exist, it would be necessary to invent him. He was thinking of just this issue. But it's not just empirical. A bunch of empirical work has suggested this. Anthropologist Rich Sosis has just looked at the longevity of religious and secular communes. Don Johnson at Oxford and Ara Noordzaya have recently written books on just this idea that the origin of moralizing gods interested in human affairs were either instrumental in the rise of axial large-scale cultures, or they followed it and helped sustain it. To conclude, no other than Dan Dennett says, we have built-in desires to reproduce and do pretty much whatever it takes to achieve this goal, but we also have creeds and the ability to transcend our genetic imperatives. This fact does make us different. I would actually say, by the way, that it's not clear we're transcending our genetic imperatives. That may be the veneer theory again. We may be harnessing them and extending them. But this work having to do with moralizing gods and the notion of creeds is much about the control of defection. There's one most recent and largely unexplored area involving not religious belief, but religious experience. Here, you know, the Christian New Testament says that we comfort others in trouble with the comfort that we ourselves receive from God. There's some notion that the experience of the acceptance and comfort of God in our lives, now by the way, whether there is such a God or not, it enables us to extend it to others. My colleague, David Sloan Wilson, who's not a theist, refers to this as a useful fiction, that there isn't a God, but some people experience his presence and it really helps. I myself don't think it's a fiction, but in any case, we have been doing work over the last few years in our lab in commerce with a behavioral neuroeconomist, where we bring people in, we have them do different group activities, singing, playing a game together, worshiping together, and then we have them play a series of economic transfer experiments. One of them is called the Dictator Game, where I get Andrew $10, and he can decide how much of it, if any, to give to Kevin. And we find that offers after worship are about double from other economic activities. And, you may see where this is going, the amount of offer appears to be mediated by oxytocin, which we assayed before and after these group activities. So, where do we end up? Evolution and the capacity for love. Certainly, it has evolved and increased, but I want to distinguish and caution between the existence of biotic capacities and inevitabilities. There are some things which are sufficiently biologically instantiated that there's very little deviation unless it's pathological deviation. You're 98.6. Oops. But these are capacities, they're not inevitabilities. And secondly, to whatever extent we have capacities, our capacities are ambivalent. We have the capacity for attachment and love, but the capacity for great violence and injury. And in fact, that's a biological endowment. So we have ambivalent capacities. And then a comment on the relationship of capacities to ends. So Aristotle viewed organisms with distinct ends that we can infer from those organisms' capacities to reach those ends. In our case, we have capacities. I've shared with you a number of studies that suggest that measures of human flourishing, physical health and emotional health, are tied to the enmeshment in loving relationships. It turns out that the relationship between those capacities and ends isn't inviolate. That culture, for example, profoundly mediates that. And that brings us to the final point, a theological point of the relationship between capacities and grace. So theologians speak of common grace. That's the deposit of goodness in all creatures by virtue of their having been created. And special grace, which has to do with maybe special needs, our special needs for divine help in realizing things for which that are consonant with our endowments, but which our endowments themselves are not entirely sufficient. And I want to thank you for your attention, and would love to have some questions and discussion.